All right, we're going to look at an air traffic control scenario and how to decide if the aircraft can fly safely from their starting points to the VORA, which is their destination. Could be an airport, whatever it is. Okay, so the first one's going to fly through VOR1 to A. The next one's going to fly through VOR2 through A. And the last one's going to go VOR3 through A. We have a choice. They can go through that path. They can actually change their paths. Okay, so those are our choices. But what we want to do is figure out, maintain at least 3 nautical miles separation, and we can adjust their speed by plus or minus 25 knots. But we want to try to avoid delaying the aircraft any more than we have to. And so the first thing we need to do is we want to look at, for our GDH51, we know his distance he's going to travel is 50 nautical miles, and we know that his velocity is equal to 480 knots. Okay, and then for the next one, for the CMG 10, we know that he is at 47 nautical miles, and his velocity is 415 knots. And our last one, which is the KMT32 down here at the bottom. His distance is 48 nautical miles, and his velocity is 475 knots. That's what they all start out as. Now we want to solve for time for each one of those. And time, if you remember right, distance equals velocity times time, so time is equal distance divided by velocity. And so we're going to use that equation in order to help us solve for the time for each to see which one will get to the VORA, the destination, quickest. Okay, so time is equal distance divided by velocity. In this case, it's going to be 50 nautical miles divided by the 480 knots. And we're going to get that the time is something. Let's get our calculator here. And we get our time is 50 divided by 480. And it's going to be 0.1042. 1042 hours. And then if we look at our second one here, we're doing the same thing. We're solving for time. It's again distance over velocity, which is now 47 nautical miles over 415 knots. And so my time is going to be equal to 47 divided by 415. And we get 0.133 hours. And my last one, my time is going to be, again, distance divided by velocity. Now my distance is 48 nautical miles, and my velocity is 475 knots. 48 divided by 475. And we're going to get the time is equal to 0.1011. Okay, now we're going to look for the shortest time. This one here, if we notice, is the quickest time. And that means that this aircraft, the orange one, is going to get here first. So the orange one will be sitting right here at the airport. Okay? And we want to figure out where the other two are when he gets to the airport. So we're going to use his time and put it back with these two things. So we're going to take now and solve for my distance. Okay, because distance is velocity times time. But it's going to be times the orange time because that's the one that's at the airport. We want to see where the others are at that time. Okay, so it's going to be my velocity of 480 knots. And we're going to multiply that times the 0.1011. Okay, we're going to do the same thing with this green one. We're going to say distance equals velocity times time, which is equal to the 415. And again, times the 0.1011. And let's see what we get when we do all those. So 480 times 0.1011. And we get 48.5 nautical miles for that guy. And then 415 times the 0.1011. And we get 41.96. Or we'll just say, 41.96 nautical miles. Okay, and we know this one, he already went the complete 48 nautical miles because he's there. Okay, so our distance here is 48 nautical miles. Not that it really matters, but we know that he got to that point. So the green one went 41.96. So where is he here? Well, he started at 47, so we're going to subtract to see where he ended up. We're going to say 47 minus the 41.96. Minus 41.96. And we get that he's at 5. We're going to round this off and just say that it's at 5 nautical miles out. Okay, so if we look here, the green one is sitting right there. Okay, and now we're looking at the blue guy. He started at 50. And he's gone the 48.5. And so we're going to do this, 50 minus the 48.5. We're going to see that he's 1.5 miles out. So he is just right about here. Okay, so he's very close to the other. And so we can see already that this one here, this guy's sitting at 0, right? He's at the 0 spot. He's at the airport. This guy's only 1.5 away. He's supposed to be at least 3. Since he's not 3, not good. Okay, we're too close. We've not following the right characteristics. Okay, so our separation for this is the 1.5 minus 0, so we're 1.5 nautical miles, so that's bad. This one is 5 minus 0, so he's 5 nautical miles, that's okay. And then between these two, right, he's 5 away, and this is 1.5 away, so the 5 minus the 1.5, 3.5 nautical miles, and that's between the green and the blue. Okay, so that's between the GDH and the CMG. This one here is between the KMT and the CMG, and this one here is between the GDH and the KMT. So we just have to adjust something now. We have to decide, okay, he's a lot closer, so we could slow this guy down a little bit, or maybe we could speed this guy up. If we got him there faster, then this guy would still be farther away. This guy would still be farther away. So that would be my first guess, is to just try to make him faster. So we're going to make the velocity go up on KMT 32, and maybe we'll make it up to, 490. Okay, knots. Or you can make it 500, because we can go up a full 25. Okay, and then we just run this again. So now you solve this again, and we say that my time is now the distance over the velocity. The distance is still the 48 nautical miles, and my velocity now is 490. And so now when we do this, what did I say? 48, sorry. Divided by the 490, we get that my time is now 0.098. And then we go back through and we solve for these distances again and see how far away they are. And once we figured out how far away they are, we determine, are we better, right? These two are good, this guy was bad. So now we see where we're at. This guy's still going to be at the airport after the 0.098 hours. Where is this guy? So again, we're going to multiply the 480 now by the 0.098. And we can see that he's at 47. Okay, so now this guy with our new stuff is 50 minus the 47, which is 3 nautical miles. And so that works for that one. Now we just have to check these other two to see if they also work. If they work, then our scenario is good. If not, we adjust something else. And so it's just a guess and check kind of, but use, an educated guess to try to figure out which one would be the best one to change. And we try to not delay anything, and we try not to increase or decrease our speed by more than 25 knots, but we have to have at least 3 nautical miles between each aircraft. Hopefully that helps.